Alright, so this is your answer key video for the practice test for Unit 1, which is all about numbers, if you remember. So, we're going to start off with numbers 1 through 6, which is just a review of really it's just subtracting, multiplying, and dividing of different kinds of integers. Alright, so let's first look at the subtracting. Now, you might remember the fact that two negatives makes a positive. That is just if there's two negatives next to each other, or if you're doing multiplication or division. So in number 1, I want you to just take it left to right. Negative 2 minus 8. So if you want to think of a number line up here, I will put this up here. 0 is right there. That is a negative 2. If you start at negative 2, you're going negative 8. And if you remember, negative or subtracting 8 goes into this direction, the left direction. It'll take you farther into the negatives all the way to negative 10. So two negatives together, in this case, makes it a farther negative. So it's negative 10 is your answer. Here's where two negatives can make a positive. In number 2, when you have two negatives next to each other, they both become positive, and it changes to 7 plus 6, which of course equals 13. Number 3, here again we have the two negatives next to each other, so make them both into positives, and then you have negative 4 plus 6. Alright, so now one of them is a positive, one of them is a negative. If it helps you, you can go up here again and say, alright, here's negative 4. Oh, weird 4 there. But if you start at negative 4 and you add 6, you go into the positive direction, so you go up 4, 2 more gets you to this number 2, which is your answer, which is 2. You can also think of that tug of war we talked about. When you have one negative and one positive for adding here, you just think of which one has the bigger absolute value. And in that case, it would be the 6, because 6 is a bigger number than 4. So we know it's going to be a positive answer because it has more pull from that 6. So you have a positive 2 because the difference between 4 and 6 is 2. All right, going on to multiplying and dividing. These rules are quite simple, and you can take a look at the cheat sheet that I made for you guys. It's on Moodle. You should also have a hard copy. But when you multiply two negatives together, so in this case, when you multiply or divide two negatives, that makes a positive. So multiplying or dividing two negatives makes a positive. So you're going to have a positive, this time 2 times 20 is 40. And same thing for dividing. Two negatives makes a positive, so 55 divided by 5 gets you to 11. It's different when you have one negative and one positive, then the answer is going to be a negative. Because it's like you're saying 5 times 1, which is 5, and you still have that one negative out in front. If you want to look over here, this would be like 2 times 20, which is 40. And there's two negatives, and we know from adding and subtracting, when there's two negatives next to each other, you make them both into positives. So that's how you get the positive 40 there. But this stays as a negative. All right, scrolling down. These two are looking for expressions. I want you to write the expression out how it would look. So the keywords here are sum in this one and product in this one. You got to know what they mean. So think hard. Sum actually means addition. So the sum of 5 and 12 would be 5 plus 12, which, of course, it says to evaluate, and we know that that is 17. Product means multiplication. So we're going to multiply the product of 2 and 20, so 2 times 20, which equals 40. Now, if you're going to, so sum is addition, difference is subtraction, product, we just said, is multiplication. And then the fun one is quotient. Quotient is for division. These are all the quotient. All right, quotient. I hate when that does that. Is for division. So these are important to remember because these are all what you call the answer to these kinds of situations. So the sum is the answer to addition. The quotient is the answer to a division problem. All right. All right, going on classifying numbers. Classifying numbers is a really important thing to be able to know. If you go on to Moodle and you go to this cheat sheet down here, you can open the Unit 1 cheat sheet up, um, open it up in a Word document. And this is actually really helpful, so it can help you with this multiplying or dividing here. You can also scroll down, and I have, so there's properties, and then the real number system. All right, so let's go back, and let's say, 8 over 127. Looks like a fraction. Let's see what fractions might be. Looks like we have fractions in the rational number section here. And if you want to scroll down, let's see what it says for rational numbers. Rational numbers includes positive counting numbers, zero, negative counting numbers, and fractions and decimals. There we go. Fractions. So that would be rational. All right, so we'll use red for this. That's a rational number. So again, classifying numbers is just saying what is the smallest group that it goes into. All right, and it could be rational, irrational, counting, which is also natural numbers, and then integer and whole numbers. Zero, you might remember, is, well, if you want to look back, I believe it is a whole number. So right here, look at zero is added in the whole numbers. So whole numbers include zero and all positive counting numbers. So it would be a whole number. If you look back, negatives were included in integers. Square root of 21. Now the square root of 21, it just depends on what the answer for the square root of 21 is. So if you pull out your calculator and you do 21 and take the square root of that, you get this crazy long decimal that goes on forever with no type of order to it. So really, look back here, we have a whole bunch of square roots in the irrational number section. So let's see what irrational numbers are. They include any decimal that has no pattern and never ends. So it's a decimal that has no pattern and it never ends. That's what this is. So we're going to say that is an irrational number. All right, we're almost done with this. 9 is just a counting number. All right, so we can say counting or natural. Positive counting number, or we could say it's a natural number. They are the same things. And then pi. If you know anything about pi, it really never ends. And a great example, I think it's listed on here in this little table. And there it is. Pi is irrational. You should know that pi is an irrational number. And I want you to know that all of these are real numbers. They're all real numbers, but they're just different types of real numbers. All right, so when we ask you to classify real numbers, this is what you're doing. All right, on to page 2. On to page 2, this has to do with properties. All right, so if you want to look on that cheat sheet again, just to help you study. All right, properties are right here. There's 5 of them. Let's just review them. Commutative has to do with changing the order of addition or multiplication. And it'll say the same answer. So we have 2 plus 10 is the same thing as 10 plus 2. Same thing with multiplication. Skip down to associative. That has to do with parentheses or grouping it. So the only thing that is changing is where you put the parentheses. So for right here, if we're looking at this example here, in this case it's 2 plus 10 plus 4. And it looks like in the second, it's also equal to moving the parentheses around the 2 and the 10 and leaving the 4 outside. Works the same for multiplication. So just changing where the parentheses are for addition or multiplication. Third one is the identity property. And if you remember anything about identity, it's who you are. And if we're talking about numbers, it's what that number is. So in this case, we have 22. And if you add 0 to 22, it doesn't change its identity. It stays as 0. So you can add 0 to any number without changing it. You can do the same thing with multiplication. You can multiply any number by 1, and it won't change the identity. So that's just stating the identity property. The zero property of multiplication, simply put, this is something that you learned when you first learned multiplication a long time ago. When you multiply anything by 0, the result will also be 0. Whether it's a number, a variable, multiplying by 0 will make it 0. And then lastly, the negative property. The negative property says when you multiply or divide a number by -1, it just makes the result have the opposite sign. Okay, so in this case, 7 was positive, and you multiplied by -1 makes it a -7. And the second one, 7 was negative, so it's a -7. It changes the sign by multiplying it by -1, changes the sign to +7. It works the same for division. 7 divided by -1 makes it a -7. -7 divided by -1 makes it a +7. So that's the negative property. All right, so let's use those real quick. Number 15, looks like there's parentheses, so does it just change the grouping of the parentheses? I believe so. That would be the associative property. And to be more specific, it would be of addition. I'm not sure why it's doing that. All right. Now, 16. 3 times 8 equals 8 times 3. Looks like they just changed the order there. So if you think of changing order, you think of commutative property of no, this one's of multiplication. All right. Ooh, multiplying by a 1. I don't get confused between a -1 and a 1. This is multiplying by a 1, and it did not change its identity, so that's the identity property of multiplication. All right. And number 18, another thing you're doing to the identity, or it didn't change it, so this is the identity of addition. All right, new section. Absolute value. What does absolute value mean? Absolute value if you remember back, equals the distance from 0. And you should know that distance from 0 is always going to be a positive value. So if we look at number 19, the distance away from that -9 is away from 0 on the number line is just 9 spots. So your answer is 9. Now 20 is looking a little bit more like you're doing a couple things in here. First, you have to figure out what -5 minus 6 is. That's going to be -11. That's still inside of here. And you subtract that by, you can do, well, we're going to have the absolute value of -13. All right, now let's simplify each of those. Absolute value of -11, so it's -11 is 11 spots away from 0, so it is a +11 minus a +13, and that equals -2. All right, number 21 is pretty complicated, but it's not too bad. Let's start simplifying things inside first of all, and I'll use red for up here. 5 minus 9, you get -4. That's still in the absolute value symbols. Plus 2 minus 11 is -9. And then down here, -1 times 13, so that's -13. Still in the absolute value signs. And that's all inside of a big absolute value sign here. So let's simplify that. We have 4 plus, that's a +4 plus +9, because it's always going to be a positive when you do the absolute value. That's going to be 13 over +13. And we know that that is 1, because anything over divided by itself is 1. And the absolute value of 1 is 1. All right. Let's go down to the bottom here. -6 times 3, you get a -18, because 1 is negative, 1 is positive, and when you do that for multiplication, the answer is a negative. And -18 is 18 away from 0. So your answer is 18. And then lastly, Let's just do what's inside of here first. Negative 1 minus 5. So you have to think. It's negative 1 degrees outside, and it goes down 5. You're down to negative 6. So the absolute value of negative 2 plus the absolute value of negative 6. So this will be 2 and 6. Add them together, you get 8. And there you go. All right, last one on this page, we've got just a little word problem. It says Hannah gets 93% on her driver's test. Sounds like a pretty good grade to me. Jim gets 88%. What is the difference of their scores? Now, if you remember difference is subtraction. So if you have 93% minus 88%, your difference there is a total of 5%. That's all we're asking. 5% difference there. Hannah beat Jim by 5%. All right, third page. Let's finish up strong. We'll do a couple order of operations problems. Remember PEMDAS, P, E, M, D, and remember M and D and then A and S. Those are, do them at the same time, do those two at the same time. Doesn't matter the order, go from left to right. So let's check parentheses first for number 1. So that was at the P parentheses. We've got parentheses right here. So let's do everything inside of the parentheses. And remember, inside of the parentheses, you do the multiplication before the addition. So that is 14. 7 times 2 is 14. You can add that to 6. You have 8. And then 6 plus 14, times, this will be 20 minus 30. If you can do 8 times 20, because again multiplication comes before addition or subtraction here, that's going to be 160 minus 30, which equals 130. All right, number 26. Don't be fooled by the fraction bar here, or the division, whatever you want to call it. Just do everything on the top, and then do everything on the bottom, and then you can divide it out. So let's start with the top. This is equal to 3 times 3 times 3. Which equals 27. Right, so we have 27 on the top. We're going to have on the bottom. Let's do all the parentheses first, because that's the first thing we should always be doing. And then inside of there, you got to do multiplication first. So that's 10. 4 minus 10 is negative 6. So you have 3 times negative 6, which we did actually before. You're going to get a negative 18. All right. So 27 divided by negative 18, you're going to get a negative answer. You could leave it as this. I actually would want you to reduce it a little bit. You can divide both of those by 9, and you'll end up with a 3 over 2, and that's a negative 3 over 2, or negative 1 1/2. All right, now I'm going to let you figure out the last one. Make sure you do parentheses first. There's no parentheses. So try the exponents first, and then do any multiplication or division, and then you can do addition or subtraction from left to right. All right, and here's the very last thing that we've done. It does have some estimating. You do have to estimate. So you're going to have to know your perfect roots. Cube roots, though, we're looking for a number that, when multiplied by itself 3 times, gets you to 27, and that would be equal to 3, because over here we can do 3 times 3 times 3 equals 27. Cube root for 64, what times itself 3 times gets you to 64? Let's try 4 times 4 times 4, since that's a little bigger than 27. That actually does equal 64, so our answer is 4. All right, cube root of 130, I don't think there's a perfect one for that. But if you think, the cube root of 5 or 125 equals 5. we'll estimate that's a little bit higher than 5. We'll say approximately 5.2-ish. Sorry about that. So 5.2-ish. You can check it on the calculator. Let's say 5.2 times 5.2 times 5.2, and that didn't work. 5.2 times 5.2 times 5.2. So it's about 140. So maybe we'll go a little bit lower, and we'll say 5.1. Alright, so it has to do with estimating. And all these square roots are estimating as well. You have to know what's on either side of them. So we know the square root of 16 equals 4. Square root of 25 equals 5. So our answer is somewhere between 4 and 5, probably about right there. We'll say it's approximately equal to, I don't know, 4.1 again. Same thing here, we got the square root of 49, we know that one is 7. Square root of 64, above that is 8. So this is just above 7. So let's say it's about right there, approximately equal to 7.1. And then lastly, we know this is just below square root of 25, which is 5. So let's say it's right about there, which is 4.9. And there you go. And you can check these on the calculator just to see if they're close. It says evaluate exactly if you can or estimate. And that is the chapter 1 review. It's all about numbers. Make sure if you have any questions, you can email Mr. Pouts, and he'll help you out.